first talk of the day is spoken by Radu, who is here with us. Hi, Radu.
Hello.
Well,
Hi.
nice to meet you.
Same here.
Let me say a few words first so the audience knows more about you, for those who don't. Radu is VP of Cognitive Computing at Endava. Well, he likes data, like a lot. No matter if it's acquired from different sensors, such as depth sensing cameras or mobile robots or microphone, well, he likes it all and uses it to create systems that enhance the user's abilities. That is when he doesn't take 3D scans of his kids. What's up with that, Radu?
That was a way to keep some memories, not only in 2D.
That's really cool. And do you 3D print them or just scan them?
I just scanned them. It was pretty hard when my daughter was like 2 months old, so she couldn't stand still.
Yeah, I can imagine it's a challenge for smaller children.
Yep.
Well, you're going to talk today about augmented intelligence using systems level thinking. And I want to ask, in your talk, you've redefined AI as augmented intelligence and not artificial intelligence. And did you do that because you find that augmented intelligence will be the, let's say, overarching paradigm for the next decade?
I think so. Actually, there is a key there in this term, which means that technology should help people, not replace them. This is something that I'll repeat over and over, and that I'm a big fan of, because actually this can help us overcome the rejection that is usually encountered when trying to push some technology too hard.
Yeah, I remember a company used to have that mantra, embrace, extend, extinguish. So maybe the machines will do that for us.
Well, hopefully not.
Fingers crossed. Fingers crossed. If you want to start telling us more about how augmented intelligence will not destroy the human race, I can't wait to see that.
My pleasure. Let me share my screen now so that I can make the presentation visible. Is it okay?
Yeah, we see it.
Okay.
All right, so full speed ahead, and we'll be here and we'll be asking you some questions at the end.
But I'm trying to get rid of this. Okay. So, first question, and I think many of us working in the field discovered that we face this cliche of machine learning being the genie in the lamp. This means that we face some very high expectations from our customers. We think that problems can be solved just by rubbing the lamp, and poof, the genie will solve everything. And one interesting way to put it is by Casey Kozyrkov, who said that machine learning means automate the ineffable. So in 3 words, she sums up pretty good what the machine learning aims to do, is to deploy solutions without explicitly programming them with rules. Now, in a nutshell, anything that is structured, repeatable, or predictable will be automated. Of course, if we have enough computing power and data, which seem not to be a problem nowadays. And what is cognitive computing? Because I'm dealing with cognitive computing every day. So these are those technologies that augment the capabilities of people and allow us to better understand the processes through forecasting and process simulation. So here is what I mean by augmenting the capabilities, and where I think it appears. So the way we interact in business and in our private life is currently changed by the network of digital tools and devices that communicate between themselves. And if we place cognitive computing, as I do, in the center of the universe, we can see that it involves machine learning, it involves IoT, it involves some tools that can define or change the strategies of the companies, and it gives a lot of insights through data. But more important is that the change is catalyzed by this kind of interaction between multiple systems that end up by summing up more than the value or the of their individual components. So in this case, you can see that we get data from many places. We can get data from health devices, from navigation devices, from finance applications, from a lot of sources. And they all kind of combine together and define a system which is actually can be comparable to a cloud of entities that have a degree of autonomy, and together they define some shapes in space, in this imaginary multidimensional space. Now, cognitive computing can be also seen as intelligent digital mesh. Intelligent because it leverages all these machine learning algorithms, digital because it focuses on the blending between the digital and the physical world, and mesh because we have here to face connections between devices, people, and organizations, which leverage different technologies. Therefore, cognitive computing redefines AI as augmented intelligence, as we discussed at the beginning of our talk. So how can we approach complex situations? Usually, situations involving machine learning are not very straightforward, or they don't have a very clear cause-effect relationship. First question, how to deploy AI in the real world? And there are some elements that I'd like to share with you. One is data, then the AI talent, and I think we have plenty of data, and the AI talent is growing. But the third element is quite overlooked, are the cultural challenges in bringing AI into existing businesses. And I'd like to stop a little bit on this here and see what it involves. It involves initial training, and it involves working with data so that the systems that we deploy are compatible to the existing systems, with the existing systems. We have to convey the idea that uncertainty must be accepted. So people are used nowadays to deal with rules and procedures, but artificial intelligence works more like our brain. It doesn't calculate the exact value of an action. So we should be able to understand that sometimes the result is not black and white. There must be some shades of gray. Good communication between all the actors means that all the actors involved in the process have to be kind of aligned. So we need to communicate between business teams, IT teams, data teams, and so on. And then convey the idea of supporting people and not replacing them. This is also very important. Now, let's not forget the Peter principle, which says that people in a hierarchy tend to rise to their highest level of incompetence. This means that usually people that we meet in other organizations that we're working with arrived there because they were really good at what they're doing, so they got promoted until they reached a level from which their capabilities are proven limited. Therefore, it's advisable to have that empathy and understanding for our counterparts when trying to implement an AI solution. Now, how to take action on emerging trends, and I think this is really important, and I wanted to include this in the presentation today. Every time we have a project, we should look at strategic time horizons. We, and I particularly, learned this the hard way because we have to align with the top management or with the main stakeholders and understand when do they expect results. In my case, I was in charge, together with my colleagues, of building an R&D department in a large company. And we started with a vision that was 2 to 5 years. So we started to do some strategic planning, some hiring, some learning ramp up. And we discovered after a while that actually we were supposed to deliver in less than 1 year. So we should have done things in more tactical way rather than defining all these elaborate strategies and implementing some things that were going to give fruits in a few years. Then moving forward, you can have the luxury of building a vision, and then there is room for R&D, there is money for investment, and this is typical for research departments or for universities. And the last frontier would be those projects that bring system-level disruption. And here is the example of the smartphones, which really changed our ways of interacting with the world and among ourselves. So these are the strategic time horizons that we have to take into account. And we can move forward and look that when we're talking about innovation, we have usually two actors. We have the operational team and the innovation team, or the startups that can play the same role. Each of these parts, they have a set of values that are valid and understandable from their historic point of view and evolution, but only a few are common. The rest, for the rest, we have to bridge the gap. We have to make somehow to do things that with the support of the organization, with the support of all the C-suite and the operational staff, we have to make the two parts understand themselves and work together. So usually the operational part that I'm referring to are those people that have done business and are used to deliver results in one way. And then there is the disruptive way of doing things, which is advocated by the innovation department, which usually involves some kind of AI or machine learning or something like that. And in many cases, we will face pushback from the participants from both sides. Now, these are the provider issues, and as talking from the provider's perspective, I discussed how to take action on emerging trends or understand innovation, but there are many more questions to ask. How to sell innovation, how to deal with the social effects of automation, how to implement and maintain a network of internet-connected devices or connected otherwise, how to ensure security, how about those legal requirements, how about those environmental constraints, and so many others. So from one side, we have those issues, but what about our customers? Well, their management has to deal with an unprecedented degree of uncertainty too. And actually, they have the same set of questions. So we're all in the same boat, basically. Now, the 4 pillars of effective onboarding are business orientation, stakeholder connection, alignment of expectations, and cultural adaptation. Each of these, I found this very interesting classification or approach in a book called The First 90 Days, which explains how a new employee can hit the ground and run in the first 90 days in a new organization. And I think everything applies to AI too, because if we're talking about a smart and autonomous solution that is deployed inside the veins of an organization, it can be seen as a new employee. So it has to understand the business orientation. It has to be connected to the stakeholders. People have to have their expectations aligned, and of course, any solution has to take into account the cultural biases or the cultural background of the users. So one tool that I like to mention here is the Canadian sense-making model. This is a framework which was proposed by Dave Snowden and divides the world in 5 parts. At the middle, we have the chaos. We have actually the disorder. So we don't know where we are. And then from there, we can fall into one of the 4 categories. The best practice are the ones that there is a clear relationship between cause and effect. So we apply best practices, we sense, we categorize and respond. Then there are the complicated situations in which the relationship between cause and effect requires some kind of analysis or investigation. And here we apply something called good practice. So we sense, we analyze and respond. Then there are the more complex situations in which we can perceive the relationship between cause and effect only in retrospect. And here we have to probe, sense, and respond. So kind of research activity. And finally, the novel practices are act, sense, and response, because they are those that have to be applied in the chaotic situations. And a nice way of representing the same thing is presented on the right, in which it's shown in a more funny and graphic way how you start from the confusion in the middle, and you can fall from what we think is a clear or known or familiar situation into the chaos. And this is what happens many times when we're trying to apply machine learning or AI to situations that we think are very clear, and we try just to replicate the digital processes in technology instead of looking at other elements that are involved in the equation. So enough about these abstract things and about these theories. Let's see some real examples. I will present 2 projects that we developed recently, and I think that I can illustrate how we apply all the above. First of all, let's see how a typical machine learning project looks like. We always start by collecting raw data. We merge the data sources. As the presenter said, I really like data sources, and I really like gathering data from different sensors. And what we have to do then is to clean the data, apply something called feature engineering, construct the model, tune the parameters, which means train the model, then validate it and deploy it. The parts that are the most time-consuming and effort demanding are the feature engineering and the parameter tuning. One of the first challenges, one of the 2 challenges that I wanted to show you has been presented by one of our customers, a travel insurance company, which needed to build a system that could help them deal with expenses recovery incurred by a health incident. So tourists go into holidays, they have some health issues, they have to go to the hospital, and then they get a medical letter. Then based on that medical letter, the insurance company can accept or reject the expenses they had. In this case, we came up with a solution through which the customer sends the documents by email. Our intelligent system extracts the email from the attachment. It extracts the images from it, and then we apply image processing and character recognition that in order to extract the text from the PDFs or from the images that can be even pictures of the medical letter. Then once we have the text, we translate it into plain English. Usually these were letters in Spanish. and then apply document reconstruction and send the email back. In order to develop this solution, we used Microsoft technologies, but we also had something else involved. We involved data science, in which we had to deal with gathering the data, building the model, and deploying it. Data gathering was one of the most demanding steps, so we had to make sure we got medical letters that were in a high volume, that were varied enough so they don't look all the same. We had to see if they're anonymized. These were some legal issues. So we managed to gather the data. Then the first idea would be, okay, we're done. But no, we had to deal also with MLOps, which is the DevOps for ML. So how we develop the solution, how we make it a product, what are the operational parts, like deployment and infrastructure, monitoring, CI/CD. And then there were all the discussions with the business domain experts. We started from a set of initial assumptions, which were that we wanted at the beginning to upload the images in a browser and then apply some the similar set of techniques and then extract and present the translation. But it showed that talking to them, we discovered that this is not how they were best helped by the solution. So we changed it to send an email with the PDF. Then we had to deal with some domain-specific terms because there is that medical slang that has to be taken into account. And we had to build some kind of a dictionary which took into consideration different terms that had not the same meaning as in our day-to-day speech. Then we got some deeper insights from the experts, like how fast the translation should be done, what is the quality, what are the costs of the substitutes. So how are they doing before? They hired a company which had human translators that received the documents, and in a week they sent the translations back. So it had a cost, so we had to be cheaper than that. And then what was the accessibility for the end users? Then we should also take a look at the economic part. What's the addressable market? What is the impact of the COVID-19 crisis on tourism? What's the disposable income of customers? So this actually was a red flag, the COVID-19 crisis, and our customer, for now, once the project was deployed and proved successful, postponed the general use because tourism really hit bottom and they didn't have enough demand for their insurance. And then the social aspect is how can we alleviate the tourists' incidents? How can what are the demographic characteristics of the tourists, and what are the cultural norms? The emphasis on safety, some cultural barriers, and so on. So with all these gears, we had to build living solution, not only with data science, not only with machine learning. The second project was another challenge by a customer who needs a tool for enhancing the capabilities of analysts to understand some publicly available financial calls. And such a solution shall be able to understand who's talking, what each speaker is talking about, and get some insights in the emotions of the speaker, search for topics of interest, or even produce the summary of the discussion of parts of the discussion. In this case, we used the same approach. So we gathered the data, which was also hard, again, a hard thing to do, because we had to get audios and videos from publicly available calls. Then we chose a model, in this case, natural language processing from Microsoft again. So the model, there was no question to build one from scratch. So we are leveraging the existing technology and then deploy it. Of course, we had all the MLOps issues, and then involving the experts, again, we switched from our initial assumptions to a new approach. So we initially thought that we had to do the translation and the diarization in real time, but in fact, they were interested also in recorded calls, so that they could get some historical perspective on the facts. Therefore, instead of building, as we wanted, a real-time voice transcription, we had to look at batch processing and process several calls pre-recorded. Again, there were some domain-specific terms, in this case in the banking and the financial sector, and some insights from experts that wanted to use AI in order to understand the trends. So when a speaker says, okay, we are going to have this value of our shares, we should be able to look at what they said in the previous quarter, or and what to expect next. Then the economic aspect and the social aspects are also important. We looked at the economic growth, we look at the addressable market again, and then see again the cultural norms and emphasis on the cultural barriers and even the career attitude, because some of the users of our application were not so open to technology, while others, yes. So, well, you have to choose your partners. Okay, as a conclusion, there are two. Simple solutions fail because they are not holistic or creative enough, and I firmly believe this. And then something that I found interesting in an article from Gardner, the goal of AI should be replacing the technology literate people with people literate technology. This means we need technology that understands people rather than people well educated that are able to use technology after years of training. As an approach on the strategy of these projects, as a strategic approach to these kind of projects, the advice would be to start from the business problem and set some KPIs up front, and always think of the user needs. We have to think of augmenting humans and letting them do higher work, and never say we're replacing humans and not doing that. We have to secure sufficient and available funding, of course. Regarding the AI and ML process, we have to understand the data first and plan the efforts around data gathering, preparation, and analysis. I think I was clear enough during the presentation about this. Adopt an iterative approach and work by chunks and accept to fail. So many times we just find out that problem solved is not possible. Plan early for scaling and think longer term. So take into account what will happen next. And usually what happens next is that the insights that people get from AI bring new perspectives that need more AI. What are the enablers in this case? So that we have a successful project, we should define clearly roles and responsibilities with a strong business owner. We have to introduce training for personnel. We have to stop shooting for the moon, because this is the biggest temptation from technical people, to use bleeding edge technology that many times is not required. Leverage real life production data and avoid pure labs environments, although these are very important also. And regarding the change management, agility is crucial. We must have a high degree of adaptability. So we have to stop rubbing against the ML lamp and look at the whole ecosystem, and then we'll be able to provide really useful solutions to our partners or clients. Thank you. And if there are questions, I'll provide answers, hopefully. And if you have questions after the session, then you always can contact us through email or the communication channels we have.
Thank you, Radu. We actually have a couple of questions right now.
Okay.
Right. One of them says, I think that the most time-consuming tasks in building a machine learning project is collecting and cleaning data, because, well, it cannot be automated so easily. Why do you think that adjusting parameters would be more time-consuming, as this can be automated in theory?
I said these are the two parts that are the most time-consuming, not the model training is more time-consuming than data cleaning. I think they're just two of the main, like on top two time consumers of ML projects. So of course, you can automatize them, and many times we do that, but there are cases in which there is quite a lot of effort involved in this process.
Do you think automated ML might be used to, well, augment the skills of data scientists, be them junior or more senior?
Mm-hmm. I think that's a good direction to go in. I don't think this is especially suitable for juniors. I think I would rather keep it for later. So at the beginning, you need to really have some solid foundation, understand all the possible algorithms, and then go to AutoML. If you go there first, it's like you're trying to write books before learning to write.
Using GPT-2, even.
Yeah.
Something like that. Yeah, fair point. So, how would you recommend somebody to get started well with machine learning? Is it just through experimentation? Is it courseware?
I would go in two steps. First, there is a vast amount of knowledge on the web, so there are plenty of resources to understand the basis of machine learning. But in order to have a motivation and a purpose, you always need a project. So definitely I would have a target, like how can I solve this problem? And then this will motivate you to move forward and try different approaches, and will avoid like that feeling of uselessness that might appear if there is just a homework.
Yeah, fair point, because just learning for the sake of learning isn't that fun. You need to have a goal, a higher goal.
And when you say not fun, you mean actually boring.
For you, maybe.
No, I remember when I got my first job, I think I had 1 week before the project started. So then, yeah, I was supposed to read certain things, and so I can learn and yeah, use that time to ramp up a bit until the team was assembled and the project was about to start. But I mean, without having a purpose and needed to build something and you learn to solve a certain problem, it got really boring. So I totally understand what Radu is saying.
Well, yeah, but it's like training. You know, you have the soccer match, or I don't know, the final exam, but you have to train for that. So yeah, if you see training like for small pieces will help you on the long run, then you may think it's useful what you're doing.
Yeah, after all, you need a goal in order to achieve things. Something similar happened to me. Then some years ago, whenever I wanted to learn a new thing, I would pick a project and start applying that new technology, be it a new programming language or library. But in the end, my project would never get finished because I would be doing it with a foreign tool. So I think there's always this equilibrium that must be found between, well, finding a problem that's challenging enough for you to approach with a new tool, and also making progress in that regard, you know, because I'm sure I would be more productive I don't know, creating an application using C# or Python than I don't know, using Ruby. Even though I want to learn Ruby, maybe I don't want to learn it that much. But back to the to the topic, I think. I also I had a question. You mentioned that, well, regarding the augmenting the intelligence and augmenting humans and, you know, machines working with along with humans. I do feel that there is a bit of a cost here, because you won't have this symbiosis for each and every person. Yeah, there will be jobs that will certainly disappear, and there will be people, generations even, that will need to be retrained. Could you tell us a bit more about this, the cost of retraining and I don't know, approaches to not fire people, basically?
Well, I'm a believer that technology can help us rather than hinder us. And from my experience, people are happy to have robots do the boring or the dangerous jobs. And it's like we have so many truck drivers which were, let's say, reconverted from horse carriers or something, I don't know, during the years. So people will always learn how to use the tools that they have, if this lets them helps them have less effort or less dangerous activities. And of course, usually one such solution can replace several people, and then only one of them will be handling the new tool, but the others will be able to apply some of their skills somewhere else. And I think we're going to that discussion of universal income and taxes for robot work and all that stuff. But well, I think this is kind of far-fetched. For now, if we manage to put the technology in as a help of the humans, we will see what the effects are. Do you remember the quadrant that I showed from Canadian framework? So we will soon be in the chaos quadrant, and then we just have to act and see what happens and then respond. We will always manage to find a good response.
Well, yeah, well, we are an adaptive species, so yeah. Nevertheless, we'll
exactly
move forward. Dan, I think you wanted to.
No, I think let's check if there are additional questions. We don't have any. Yeah, I think yeah, we can stop here. If there are more questions, yeah, people know where to reach you, and then this will be also in the video after the conference.
Sure.
So we take a break.
Before this, I have another
Oh.
small. I always have.
You kept it for the end.
Yeah, one more thing. About the prospect of achieving human level intelligence. So at the moment, yeah, we see that most artificial intelligence is, well, things that we deem as AI, basically very sophisticated pattern matching. Yeah, I think even François Chollet, the guy who wrote Keras, originally had published a document outlining the tests that we would need to make and have something that should have an artificial intelligence pass in order for it to prove it's an artificial intelligence and not a very sophisticated pattern matcher, right? What do you think about our progress towards reaching, well, not necessarily human level AI, but I don't know, dog level AI, let's say?
Well, I think right now we're quite far from there. I think we currently have a lot of narrow solutions that can be deployed for solving very, very specific problems like character recognition, lane tracking, some stuff like that. But what lacks is the connection between them. So general purpose AI will be able to juggle with different such solutions and be self-conscious. So this kind of consciousness and of interconnectedness between elements is much easier said than done. So we need to I think we need quite a lot of effort to get there and have a solution that understands how and what needs to be applied in a given context. And I've been listening quite a lot to AI podcasts. By the way, since we're talking, my favorite is Lex Friedman's. So he invites a lot of scientists and philosophers talk about AI, and there are both categories. There are people that, like Elon Musk, think AI is a bigger danger than the nuclear bomb, and there are more optimistic people that think, okay, AI is just technology. It's up to us how we use it, and it's still far from being there. I don't know. There are good arguments on both sides. I'm rather on the optimistic side, and I think just looking from the perspective of computer vision, we made awesome progress, but we're still far from what a baby can do. Like how fast you can teach a baby what an apple is, and how hard it is to teach a computer using the most sophisticated deep learning model.
Yeah, I can't wait to get to that level when we have Wozniak's, we have a machine passing Wozniak's test. You have a robot that can go into any kitchen in the entire world and just make a coffee.
Yeah.
Without any previous instructions.
Mm-hmm.
Radu, since you brought this up, so there are a few more questions. So how would you describe the adoption of cognitive AI in the near future?
Okay. So just to make sure we're on the same page, cognitive AI deals with all those edge devices that have computing capabilities, computing power, and some kind of intelligence on them, usually narrow AI. So, I mean, always narrow AI. And cognitive computing should enter our lives just like electricity did. At the beginning, there is something innovative, something that many people are reluctant to adopt, but then it should become a commodity. We should have it without realizing that it's there. So my opinion is that we're going down that road, and as we get used to these facilities that we have, we will be basically overlooking and accepting more and more technology. Just think that in a phone, we have a map, we have a camera, we have all those tools that before there was that image with a desk full of objects, and then they disappear and they got inside the phone. So something like that will happen, in my opinion, with our interactions with the world, and the impact of cognitive computing will become seamless, like it will be inside our lives.
Right. So if you mentioned commodity, then this is a follow-up question. What sort of applications do you see to be more asked for? For instance, a long while back, we had chatbots that were a novel thing, and then they sort of filled the world. What's the next thing?
From my experience, and I might be biased talking about data science, bias is one of the most important things to take into account. I think NLP applications and computer vision applications are the ones that are quite ripe for like ripe fruit. So I foresee a lot of applications of these technologies, either by themselves or combined, in which machines will be able to understand and reply by voice, or visually interact with the world and understand the world either in 2D or in 3D. So computer vision and NLP, in my opinion.
I just want to add that I love how Dan referred to technology of 2-3 years ago, like a long while back. Yeah,
It seems a long while back.
Yeah. Well, we've lived through 10 years this year only, so yeah, I can imagine.
All right. Well, I think we're yeah, the time is up. But thank you again, Radu, for this talk, and
Thank
we
you.
got a good opportunity to chat. And yeah, by all means, see you next time.
Okay, maybe in person.
One can only hope.
Okay.
All right, everyone.
Okay, guys.
We'll take a short break of 15 minutes, and then we'll regroup.